Professor, have you considered other applications for this, perhaps cross-connection? Have you considered any other applications for this? Do you think it has application, for example, for cross-connections in potable and non-potable? Or is it only for stack systems?
For cross-connections, sorry?
Between non-potable water and potable water for reclaimed water in buildings?
I think that's really interesting you asked that, because this, something very similar to this has been tried in Adelaide on the public water supply. The approach there was to generate transients by turning fire hydrants on and off in the middle of the night to generate a pressure wave, and then, but that's extremely difficult because you don't know where the problem is. Finding leaks, you don't know where the problem is. The big advantage with our system is you know where the problem could be. It could be at each trap. Whether you could use it for what you've suggested, I mean, I guess we could have a look at that, but we haven't thought of that as yet ourselves.
Thank you.
That one particular, was a papa or papo, or how do
Papa.
you? Yeah. It looks like it's some like a mechanical portion in there moving. Is there any type of study showing if there's been a failure rate in those, where maybe they collapse or they stick or anything of that nature?
Well, it's been through tests in the US. You specify tests of some very large number of PSIs, which was probably far more than you would ever get, because in actual fact the operating range of this thing is about 100 millimeters of water gauge. So that, I mean, there aren't any moving parts really, because the bag just does that. I mean, there's no mechanical device in there. There's a direct opening from the stack into the bag, and the bag itself sits inside a 6-inch, effectively a 6-inch drain, which is vented, so that that there is no contact between the inside of the bag and the outside air whatsoever.
Is there any maintenance to them? Because it appeared, and in some of them, the locations might be a little difficult to get to.
Well,
in the diagram you had there.
We've been using these things for about 8 years now, and we haven't had any issues of maintenance issues with these at all. They're pretty well a fit and forget piece of kit. I mean, you put them in and you forget about it. I mean, so it's not really too much of a problem. It's a very simple solution, actually.
I may have missed this. So what is PAPA? What's an abbreviation for?
Positive air pressure attenuator. Right. And this was kind of a joke by the wife of the owner of this company who now sells it, who she said, "Oh yes," she says, "Papa, everybody needs one." No, okay, right. I've obviously got no future as a stand-up comic, not in the States anyway. So that's what PAPA stands for, Positive Air Pressure Attenuator.
We met each other actually at the SARS Symposium. Gosh, I can't believe it was 2004.
It was a long time ago.
I think some of the attitude after seeing, as you put it, some appalling plumbing designs, I think the attitude of some of the attendees there was, well, it can't happen here in terms of the... What's your reaction to that type of attitude?
Well, we've just dealt with a case in Australia where people were trying to empty cooling towers down a vertical stack, which is clearly against their codes. So yes, it can happen in developed countries. I mean, there's no problem about that. We know it can. And I mean, the pressure surcharge thing is really about making certain that you know what the likely population of the building's going to be, because you design your stacks on the basis of what you think the possible usage is, and of course we don't know in many of these conditions. I'm sure that you have many housing projects in the US where you don't have a good handle on how many people might actually be living in those public authority housing, which is what we're talking about here. I mean, it's an uncontrolled situation. So yeah, I think that those issues are real. The other thing about the PAPA, of course, is you've got two choices. I mean, you can either go the route which we think is really a very, very promising route of actually, designing from day one with what we call an active control system, which comes from pressure surge transients in civil engineering, where you deal with both the negative and the positive transients at the design stage in that way. The other approach, of course, is to wait for something to go wrong. And then something like the PAPA, you go along and you can remediate the situation very, very easily because, you're just connecting into the vertical stack, which is, is either internal in some sort of access cupboard or it's stuck on the outside of the building. So it's quite a simple thing to do.
And I would take it the partnership approach for coordinated action to address serious issues, that would apply universally.
I would hope so, and I think that's why I wanted to actually cover those three things, because each one of them represented a different type of partnership. The first one, the PAPA thing, was something that we invented and then worked with somebody who was willing to take on the idea. The sealed building thing was an idea that we had because we then had the ability. And I must admit, we never got anybody terribly interested in security-sensitive buildings. Nobody seemed to worry about that too much. So in actual fact, the use we've put it to is perhaps more interesting because it allows you to deal with buildings which are outside the normal scope. I don't think there's a code for dealing with a flexible roof building, which actually has to have, drainage systems inside it to deal with, hundreds of thousands of people over a period of time attending rock venues. And it's going to be used for the Olympic Games in whenever it is, 2012. I think we're going to have the gymnastics and weightlifting are going to happen so some of your American contestants will be benefiting from our active control system if they actually use the facilities inside the building between lifting heavy weights or jumping over horses. Anyway, so that's good. And then the third one, of course, is something which came directly out of that symposium we had here, because we went home from that and we thought, well, this was really, I think the SARS thing was like a really, really important bookend. If you look at public health and drainage systems, then at one end you've got London in 1853 and the cholera thing, where snow proved that it was water-based. And everybody who was worried about miasma and infection being passed through the air, were trashed. That was the end of people like Chadwick who'd been pushing that idea. And then 150 years later, you have 2003 in Hong Kong, which proves that poor old Chadwick, in actual fact, did have a point, 150 years before. So you've got these two very definite bookends, which I think in future will be thought of together. Now, we came home from that symposium, and we thought, well, what on earth can we do about this? And we came up with this idea, and the following May, I think it was, we were in Auckland together, and we, this is one of Russ, an extremely kind friend. I made this suggestion at the Auckland meeting that we could do this. And I bumped into Russ afterwards, and he said, somebody was sitting next to me and said, can that guy really do that? And Russ said, well, if he says he can, he probably can. And I thought that was, thanks, Russ. I've always appreciated that comment. I thought it was very kind of you. And we have been able to do it, and it does work. And it works remotely, which is, we really enjoyed in the middle of the night, calling up the Glasgow building from the computer at Heriot and actually making this valve work and everything and getting the pressure traces back, because I think that's going to be really essential here. Our view of this for the future is that this will become a part of your building monitoring system in the same way as you monitor temperature and heat exchange and air conditioning status and all the rest of it, so that your facilities management people the next day would come in and say, well, we have some problems on the 15th floor, and we can go and have a look at that. Now, if those problems continue, then what you do is you come along with a remedial thing like PAPA, and you fix them. So I think that the two things, all those three things do actually mesh together into quite a nice set of partnerships. So I'm very grateful to everybody who's helped us.
Well, thank you, Professor.
Okay, that's been a pleasure. Thank you very much.